Basking in sunlight, a sperm whale rests after its journey from the black depths of the ocean. Sperm whales are the deepest diving of all mammals and can spend up to 90 minutes on the sea floor, hunting giant squid and other bottom dwellers. Like mammals on land, all whales and their dolphin cousins are warm-blooded and need to breathe air. So how have whales adapted terrestrial organs to a life at sea so successfully? And what prompted their ancestors to move from the land to the oceans? The blue whale is the largest animal ever to have inhabited the planet, growing up to 100 feet and weighing as much as 190 tons, or 380,000 pounds. It is also extremely rare. Only its need to breathe allows us a fleeting glimpse of its legendary bulk. The blue whale belongs to the order Cetacea, which includes the great whales and their much smaller relations, porpoises and dolphins. The smallest of dolphins is a fraction of the size of a blue whale's fluke. At a little over 4 feet, Hector's dolphins are also rare. Their range is limited to a few coastal areas of New Zealand where they hunt for fish near the surface. As mammals, whales use lungs to breathe air, rather than gills to breathe water. Whales' lungs are relatively small, but they are remarkably efficient. When a whale surfaces, it can replace up to 90% of the air in its lungs in just a few seconds. But this efficiency alone cannot account for its ability to stay underwater, in some species, for as long as 2 hours. A diving whale descends with almost half its total oxygen stored in the muscles, where it is slowly released over time. The whale uses this oxygen with great economy. Only essential organs, such as the brain, are supplied, while others go into oxygen debt until the animal returns to the surface. But the deep-diving sperm whale needs more than these adaptations. Its bulbous head contains the so-called spermaceti organ. Filled with a complex mixture of fats and waxes, one of the organ's functions is almost certainly to act as a biological ballast tank. When water is drawn into the huge nasal passages, the mixture cools and hardens, helping the whale to descend rapidly. The process is reversed by ejecting the water and pumping warm blood through the organ to liquefy the wax. All whales have bones that are light and filled with oil, which acts as an aid to buoyancy. It's also a vital energy reserve during periods of fasting. Whales are powerful swimmers, with tail flukes that are horizontal rather than vertical, as in fish. The flukes are boneless and consist of strong fibrous tissue. Powered by a pair of massive muscle blocks forward of the flukes, whales cruise at 6 miles an hour, with the fastest reported speed in excess of 40 miles an hour. Unlike cold-blooded fish, whales need to stay warm in frigid waters. Blubber, a layer of fat up to 20 inches thick, acts as thermal insulation. But whales can also actively conserve heat using warm blood pumped from the heart. Areas with little or no blubber, such as the head and flukes, operate a heat exchange system. Cooled blood in the extremities is partly heated as it passes by the warmer blood. A vital adaptation, because heat from a body immersed in water is lost around 25 times faster than in air. The very cold waters thousands of feet below the surface are the natural hunting grounds of the sperm whale. Sperm whales are the largest of the toothed whales, part of the group that includes the orca, or killer whale. With up to 10 or 12 pairs of cone-shaped teeth, orcas can threaten even the largest prey, and it's the only whale that can kill other whales. Dolphins also belong to the toothed whale group and feed on fast-moving fish and squid. Dolphins have even moved into some large rivers where they've become highly specialized. Primitive river dolphins like the Amazon buto have limited eyesight and use echolocation to find their prey in murky waters. Echolocation, or sonar, has only been used by humans since World War II, but it evolved in toothed whales and dolphins over millions of years. Dolphins emit short pulses of ultrasonic sound that bounce off objects, producing echoes which the animal uses to create sound pictures of its surroundings. Among the constantly shifting ice flows and channels of the Arctic seas, the ability to navigate beyond the limits of vision is vital to survival. Another toothed whale, the beluga, has extraordinary sensory skills, including a highly tuned sonar navigation system. Complex muscles above the jaw focus a beam of sound that produces a very precise image of its surroundings. enabling the whale to plot a safe route through channels under the ice. The belugas may descend to 1,000 feet to echolocate scarce breathing holes in the ice. Their acute hearing also helps them evade predatory polar bears. The largest whales, and therefore the largest animals on Earth, don't have teeth at all and feed on the world's smallest animals. These zooplankton in turn feed on minute sea plants called phytoplankton. Floating crustaceans known as krill are among the larger zooplankton. During the summer months, their swarms form concentrations dense enough to discolor surface waters for many square miles. These super swarms have been estimated to weigh over 2 million tons. A blue whale feeding on krill may take in 130 pounds in one mouthful, and up to 4 tons a day in the richest Antarctic seas. In a unique adaptation, some whales evolved baleen plates as a simple replacement to teeth, enabling them to harvest these swarms. Rows of these plates are suspended from ridges in the upper jaw. Baleen whales feed by simply opening their mouths to take in both prey and water. By closing their mouths and raising up the tongue, the water is expelled through the baleen plates, filtering out the food. Baleen itself is made of keratin, like hair and fingernails. From hundreds of plates hang countless hair-like fibers that can filter the vast quantities of food. Gray whales, the most primitive of the toothless whales, evolved thick, bristly baleen to rake the seabed, dislodging crustaceans embedded in the sand. Many whales spend most of their lives feeding, but the oceans do not contain endless supplies. Off the coast of Baja California, blue and fin whales hunt for food. Fin whales grow to over 70 feet on a relatively small range of foods that include krill, squid, and some small fish. Pelicans capitalize on the havoc wrought by the feeding fin whales. Large whales also require enormous amounts of food because they need to build up reserves for the less productive winter season. Humpbacks cooperate to harvest the sea, using a skillfully woven fishing net to encircle their prey. Swimming well below the surface, they weave a net by forcing bubbles out through their blowholes, while moving in a spiral beneath a shoal of fish. The bubbles drive the fish towards the center of the net. Surging towards the surface in unison, the humpbacks form an inescapable phalanx of gaping mouths. Orcas, or killer whales, cooperate in a different way. Orcas can be aggressive, intelligent predators. Here, they deliberately beach themselves to capture young sea lions. Shoreline feeding has been passed down through the generations, adults showing their young how to achieve the best results. This technique echoes the moment in evolutionary time when the land-bound ancestors of all whales first became sea mammals. At that time, 55 million years ago, the drifting continents were changing the face of the Earth. India moved north to collide with Asia, forming the massive heights of the Himalayas from what was the floor of the ancient Tethys Sea. The remaining water, which today forms the Mediterranean, became shallow and more saline, fueling an explosion of sea life. On the edges of this remnant sea, in a primeval world of tropical swamps and estuaries, lived a group of animals known as creodonts. A subgroup of the creodonts, known as the mesonychids, hunted close to the water. Eventually, these carnivores hunted exclusively along the tide line, entering the surf to capture dead or dying prey. Within a few million years, they had developed into semi-aquatic creatures feeding wholly in the sea, the first primitive whales. In the last few decades, scientists have gradually uncovered the mystery of how a land mammal returned to the sea. Near Santa Barbara, on the Californian coast, new finds like this 12-million-year-old skull of a whale are adding to an emerging picture of how whales evolved. At this stage, scientists Louise Kieran and Lawrence Barnes are not sure exactly what is inside the rock. But painstaking excavation will eventually allow them to place this animal within a complex evolutionary jigsaw, one that is already relatively complete. The whale's story begins with the amphibious animal that evolved from mesonychids. Pakicetus, the earliest known whale, still had 4 limbs as it explored its aquatic environment 50 million years ago. From then on, they evolved rapidly. Ambulocetus had large hind feet clearly adapted for swimming. Then later, Rhodocetus evolved a feature that enabled them to venture further from the land. The tail vertebrae detached from each other, allowing the tail to move up and down for propulsion. Zigorrhiza lived around 40 million years ago. It had a flexible forelimb, but the hind limb had now almost disappeared. Zigorrhiza showed another important adaptation. The blowhole moved toward the top of the head. In just over 10 million years, the early whales had left the land forever. These primitive whales had teeth designed to grasp and shear, but eventually they became modified to form long rows of sharp, uniform teeth. Today's toothed whales, dolphins, orcas, and sperm whale, are their descendants. Around 25 million years ago, the baleen whales evolved from a toothed ancestor. Even today, the fetuses of some baleen whales have remnants of teeth. For a land mammal to have evolved into the creatures we see today, such as this minke whale, evolution had to be chemical as well as physical. Kidneys became specialized to deal with excess salt. Fluids covered the eyes to protect them from the saline environment. And body hair was lost. No other mammal has a covering so sleek. These small adjustments, taken together, transformed medium-sized land mammals into huge sea creatures. At just under 100 feet long, a Boeing 737 is shorter than the largest recorded blue whale. A blue whale's heart is the size of a Volkswagen. And the whale itself is 6 times heavier than the plane. Their immense size meant that the great whales were able to fuel a hemisphere. Whale oil lit the continents for many centuries, and later lubricated the machines of the industrial age. European and American whalers made huge profits, unaware they were hunting their quarry to the edge of extinction. Whales were not only killed for their blubber. The strong and flexible baleen from their mouths was used in a range of domestic products, from corsets to umbrellas. Decade after decade, tens of thousands of whales were slaughtered to satisfy the needs of a burgeoning human population. Herman Melville's story of Moby Dick, the mythic great white sperm whale, told of high adventure, obsession, and an existence fraught with danger. By the mid-19th century, whaling methods had changed little from earlier days of subsistence hunting. It was still an intimate struggle between men and whales. And disaster was always looming. By the turn of the 20th century, even the biggest whales were pursued in the polar regions and processed in vast factories, yielding handsome profits to the new whaling magnates. Whales and dolphins are essentially social animals. For some, like these dolphins, belonging to a large group has clear benefits for survival. The chances of finding food are increased, since the group can range far wider than one individual. Collective defense against predators is more likely to succeed, and grouping helps bring individuals together for breeding. The much larger whales rarely school, and the closest bond is probably between a solitary mother and calf. Baleen whales come together at feeding grounds and to mate, but then disperse rapidly. However, sperm whales, the largest of the toothed whales, do group together in pods in warmer waters. Females form the core of the pod, which also consists of calves and juveniles of both sexes. Sperm whale bulls spend most of the year alone, hunting in colder waters. But during the breeding season, they join the pod, forming a harem. In this rarely filmed display of strange and sensual behavior, all the sperm whales in the pod form a knot of writhing bodies. Its purpose is unclear, but it may be a means of reinforcing social bonds within the pod. It may also have a more directly sexual function, since this encounter seemed to stimulate the immature males. Pilot whales also live in tightly knit groups, but they are often led by a single older female. Strong social bonds like these may hold a clue to one of the most perplexing mysteries about whales: their apparently deliberate strandings on shore. Evidence from stranding sites suggests that some animals had parasitic infestations of the ear and brain, to such a degree that it may have caused disorientation. An infected dominant female could easily lead her entire group into dangerously shallow waters. But not all scientists agree that these infestations are the only answer. Others point to magnetite particles found in the brain of several species that may be acting as an internal compass. These particles may detect the Earth's magnetic field, which originates deep within the planet and draws an unseen grid across the globe. If whales are using this geomagnetic information to navigate, it's possible that this system breaks down, leading them into shallow water traps. Spring arrives in the Arctic, and as the ice recedes, it's a time for renewal. Beluga whales move en masse from the ocean to the newly reopened river inlets. Whole whales shed skin and parasites during their lives, but belugas are the only whales that migrate to certain areas in the Arctic specifically to molt their skin. They wait for the tide to enter the freshwater shallows, where a gravel and sand riverbed will help them remove old skin. During the year, a coat of yellow-green algae builds up on the upper body, and this too will be shed. Small lead groups of beluga enter the river mouth, even though they are vulnerable to polar bears in such shallow waters. As the tide peaks, hundreds of whales begin rubbing and scratching against the riverbed and each other. After a few days, they will return to their feeding grounds in the open sea, scarred in some places, but parasite-free and with sleek white skin. With the evolution of sociability among whales came the development of highly sophisticated communication. Whales vocalize almost continuously and produce a range of sounds that is remarkably diverse. Underwater, sound travels 4 times faster and much further than it does in air. All whales need to emit sounds over large distances for identification and to locate other whales in the wilderness of the sea. In this way, whales constantly send and receive information about sex and activity. Sperm whales use a series of clicks known as codas. It appears that one whale will call and another will answer with exactly the same coda. This will be repeated on different occasions by different individuals in the group. In other areas of the oceans, populations of sperm whales have different codas, indicating the existence of dialects within the sperm whale language. One of the more remarkable features of whale communication is the plaintive, alluring song of a lone humpback whale. In an attempt to attract a mate, a male may sing for more than 24 hours, with only a few short breaks to breathe. His song may last up to 35 minutes before being repeated. A whale's song is quite clearly defined, with a recognizable beginning, middle, and end. Individual songs have their own peculiarities, their own syllables, phrases, and themes. Sound is one way of attracting a mate. However, for a female narwhal living in icy Arctic waters, sight takes precedence in the search for a suitable partner. Male narwhals, which grow to about 15 feet, have ivory tusks that are up to 10 feet long. Males joust with these elongated swords, which are both weapons and symbols of dominance. The successful competitor wins the right to mate with females, the strongest male passing on its genes to future generations. Among southern right whales, male competition is intense. The idea is not to be the first to mate, but the last. Because southern right males have the largest testes on Earth, each weighing close to half a ton, the last male to mate not only deposits huge quantities of sperm, but washes out that of the preceding males. This gives his sperm the best chance to reach the female's egg. Many whales migrate huge distances to mate, but the master mariner is the gray whale. Its journey is the longest of any mammal, an 11,000-mile round trip. From October, whales begin migrating south from the Bering Sea and Gulf of Alaska, hugging the North American coastline down to the warm water lagoons of Baja California. The annual migrations of gray whales are synchronized with their mating patterns. Conception and birth always occur in these Baja waters because gestation periods last 12 months. Calving every 2 years places enormous biological strain on those females that conceive regularly, but the warm waters of tropical breeding grounds may help sustain both females and their newborns. "12 feet long and 1,800 pounds at birth, a young humpback grows rapidly over several months, nourished by a rich milk that contains up to 50% fat and protein. Before it weans, the young humpback may increase its weight by 5 times, feeding on 150 gallons of milk each day. Apart from the occasional snack, a mother will not feed while nursing its young, even though a huge amount of energy is used up to produce such a large offspring. A mother must also protect its young from threats that can come from any direction. To a pack of hungry killer whales, any newborn whale is a tempting target. Of course, the greatest threat to all whales comes from another species of mammal altogether. Humans began whaling during the first migrations from Siberia to the Americas. These early settlers survived in a hostile environment by making full use of dead or stranded whales as a rich source of food, oil, and shelter. Recognizing the whale's value, they soon developed hunting techniques to keep themselves supplied for the long winter months. Today, subsistence whaling is still part of life in the frozen north. This narwhal will provide good eating for the weeks ahead. The skin and blubber will be cut and dried, providing food that is rich in vitamin C. In earlier days, the slower species that came close to the shore, such as the bowhead and right whales, were hunted in open boats, using handcrafted spears. Most of the animal would have been used, including dried bones used to construct frames for shelters. The annual catch of whale populations was small, and life in the Arctic remained relatively stable for many centuries, until the coming of a new threat, the commercial whalers. But today, the mass slaughter of the great whales is all but over. Conservation groups fought long and hard to close the whaling stations. But by the time mass whaling had ended, over 3/4 of the world's population of great whales had been obliterated. Communities that once depended on the whaling trade are now sustained by a new industry: whale watching ecotourism. Even though many of the whales are protected as endangered species, it may be a century or more before the most heavily hunted can recover. One positive step came in 1994, with the creation of a southern sanctuary in the seas surrounding Antarctica, a haven for 80% of the world's remaining great whales. During a 50-million-year odyssey, myriad sea mammals evolved from a terrestrial creature that hunted the shores of ancient oceans. They gradually lost those features that associated them with the land, now spawning their young into the oceans, where they would spend their entire lives. Adaptations to new food sources created a mammal without teeth, the baleen whale. New ways evolved to navigate the immensity of the sea, to dive to the bottom of the ocean and overcome the dangers of the deep. They became social animals that now hunt together, play together, and call out across the ocean vastness.